Harvard University. It's my privilege and honor to be able to congratulate you, the finalists in the Zimbabwe Science Fair for 2021. I know how hard you've worked, and you've worked under difficult circumstances throughout a global pandemic, but you've made it this far. I have a special affinity for you because when I was your age, I also entered science fairs. And so what I hope you will take from this is that if you work hard, if you aim high, you can achieve almost anything you might dream of. And if you do so, someday you could be recording this message as the president of Harvard in greeting other young people who are pursuing science and their dreams. Congratulations to each of you. Hi, my name is Larry Backow, and I'm the president of Harvard University. It's my privilege and honor to be able to congratulate you, the finalists in the Zimbabwe Science Fair for 2021. I know how hard you've worked, and you've worked under difficult circumstances throughout a global pandemic, but you've made it this far. I have a special affinity for you because when I was your age, I also entered science fairs. And so what I hope you will take from this is that if you work hard, if you aim high, you can achieve almost anything you might dream of. And if you do so, someday you could be recording this message as the president of Harvard in greeting other young people who are pursuing science and their dreams. Congratulations to each of you. name is Larry Bacow, and I'm the president of Harvard University. It's my privilege and honor to be able to congratulate you, the finalists in the Zimbabwe Science Fair for 2021. I know how hard you've worked, and you've worked under difficult circumstances throughout a global pandemic, but you've made it this far. I have a special affinity for you because when I was your age, I also entered science fairs. And so what I hope you will take from this is that if you work hard, if you aim high, you can achieve almost anything you might dream of. And if you do so, someday you could be recording this message as the president of Harvard in greeting other young people who are pursuing science and their dreams. Congratulations to each of you.
Hello everybody, welcome to the opening ceremony of the Zimbabwe Science Fair 2022. Yes, 2022. 8 science fairs later, since 2014, we're still shining our lights ever so bright. My name is Patience Munyaradzi Masikinye. I am a student in agronomy engineering at Unilassalle Polytechnic in France, and I am your host this lovely evening. First things first, congratulations to our 60 finalists for making it this far. They say success is the result of failure, hard work, and a great idea. So once again, congratulations on this big achievement. Zimbabwe Science Fair has since been a platform that allowed young scientists in Zimbabwe to freely express themselves and their passion regardless of background. It started in 2014 with only 2 schools in one province, and now we witness it attracting thousands of entries from all the 10 provinces in Zimbabwe. In addition, on Friday, we are bringing delegates from 5 p.m. to 6 p.m. to the Regeneron ISEF 2019. The Regeneron ISEF is the world's biggest science competition. Our 2019 delegates have gone on to achieve great things. On Friday, the participants will get to chat with them on how they went on to get scholarships to top global universities like MIT, Harvard, Yale, and their dreams of making the world a better place. We'll close this year's science fair with awards announcements on Saturday, 5 p.m. The awards ceremony will be hosted by Tinaya Rino Mota, a Zim Science Fair alumnus who is a civil engineering student at Mississippi State University in the United States of America. The keynote speaker of the awards ceremony is Victory Yinka Banjo. Victory made headlines in 2021 when she got scholarships from 19 American and Canadian universities. We can't wait to be inspired by Victory and Tinaya. The climax of our science fair is the recognition of brilliance and ambition. So, ladies and gentlemen, allow me to introduce the director of the Zimbabwe Science Fair, Mr. Knowledge Chikundi, who is going to give the welcome remarks.
Greetings, young scientists, parents, teachers, observers, and all our supporters. Welcome to the 8th edition of the Zimbabwe Science Fair. The Zimbabwe Science Fair empowers young scientists and engineers in primary and high schools who are working on ideas to solve our society's grand challenges. I would like to congratulate the 60 finalists of this year's Science Fair. These finalists were selected from a pool of 673 entries from across the country. We are so proud of the achievements by our young scientists. Some have gone on to turn their science fair projects into startup companies. Some have used their science fair portfolios to attract scholarships and other opportunities. They raise our flag high by scooping top awards in these prestigious competitions. For the first time in our history, this year we are selecting 3 students who will receive scholarships to travel to Imperial College in London for the London International Youth Science Forum. We wish our young scientists all the best. In this year's fair, we have over 14 special awards from prestigious partners. I would like to express sincere gratitude to my team for working very hard to make this event possible. Thank you, judges. Thank you, all the volunteers. I would also like to thank the parents and teachers for sacrificing resources and time in supporting the young scientists. The science fair will come to a close on Saturday with the awards ceremony. I wish everyone a wonderful experience in this year's fair. Please enjoy what we have in store for you. Welcome to the Zimbabwe Science Fair 2022. Thank you.
Wow. Out of 600, only 60 got lucky. Ladies and gentlemen, now we're going to show you our 60 special finalists.
Hey everyone, my name is Tanatsa Matonda
And I'm Tiliso Mufara, and we are from Harare, Zimbabwe.
In our project, we investigated how mechatronics can be used to stimulate and encourage young girls in STEM.
From Westridge Primary School, and today my science project will be about the Super Diet Bar.
Hello, I'm Kuze Mangoro from Marondera, Mashonaland East, Zimbabwe.
Hi, my name is Yolanda Fadzai Chiwewete, and I'm from Chinoi, Mashonaland West in Zimbabwe. In this video, we're going to be taking you through the preview of our project, Eradicating Epilepsy in Zimbabwe.
Wow, congratulations to the finalists once again. They say it takes a village to raise a child. I'd also like to say congratulations to the teachers and parents who supported our young scientists. There are three choices in life. You either give up, you give in, or you give it your all. With us here today as our keynote speaker is a lady who has really given it her all. Allow me to introduce a 15-year-old who is passionate about making an impact in the sustainability sector, currently developing transparent and flexible solar cells, leveraging nanomaterials, as well as building a bioplastic from duckwood, where she is working with pond biomaterials. Outside of STEM, she is the author of Chronicles of Illusions, The Blue World, which was published when she was 14. Recently, this lady was named the youngest recipient of Canada's Top 100 Most Powerful Women. She published an inspiring year in review last year. Her name is Naila Mulu. Naila is wonderful just like you, and we thought having her as our keynote speaker will inspire us all more. Welcome, Naila, and over to you.
Thank you so much for having me. I have a slideshow. Should I just show that right now? Yes. Cool. I can share my slides. Awesome. Awesome. Can you see that?
Yes.
Okay, awesome. So hi everybody. I'm really excited to be speaking to all of you today, and congratulations on getting it so far. It's really incredible, and I was looking over all of your projects and they are so impressive. So just congrats on getting here. I'm really excited to be speaking to all of you. Thank you so much for that introduction. I'm Naila, and I'm a 15-year-old really interested in the sustainability space. And so right now within the climate sector, I'm working on a few projects. The first is a transparent and flexible solar panel, and then the second is a bioplastic. And I also have been getting into coding lately, so I just built an algorithm to predict the output of solar energy power plants. So I kind of want to get into the main driving factors that helped me work on these projects. And I'm sure that you guys are already doing a lot of these because you are working on really phenomenal projects yourself. So I think that the biggest thing for me has been curiosity, and that's been led by researching and networking. And so when I looked into solar energy, to get to wanting to build a new concept, I was just curious about the energy sector. And so towards the end of 8th grade, when I was driving to school or driving home or to the mall or wherever, I noticed that there were a lot more solar panels being put up. And this was really exciting to me because I thought that we were making this shift to more renewable energy platforms. And so then I looked into some very basic statistics. I was like, how much solar energy are we actually using? And it turns out that it only accounts for 3% of our global electricity generation. And that's really low. And I found that very unimpressive, a little bit disappointing, honestly. And I started looking into why this may be, because I was seeing more solar panels. And then I noticed this issue of accessibility, because again, solar panels are pretty much only placed on roofs and in fields. So I started thinking about, wouldn't it be really cool if we had a transparent and flexible solar panel? So something that could pretty much go on any surface. You could put this solar panel on your windows, on your cars, maybe even on your phone. And then when you were typing outside, like your phone could be charged by the sun. That would be really cool. And so I started looking into how I could do this. But again, like that just started with a curiosity about solar energy. And then that turned into research. It was very basic research at first, just like understanding how a solar panel works. I did not know. And then going a little bit deeper, so I started looking at the intersection of solar energy with nanotechnology. And nanotechnology is when you're working with these materials on a very, very small scale. And when you are on such a small scale, these materials have very exceptional properties. So I was intrigued with this intersection. I really wanted to come up with an idea for a new type of solar panel that could be placed on any surface. And so I started doing deeper research and kind of coming up with an idea. But then it did occur to me that I was still like 14 years old and I pretty much had no expertise in solar energy. And there were people who had years and years of experience within this sector. And so I discovered LinkedIn, and this was maybe like one of the best things that I've done in terms of like being able to build projects and within STEM, which is getting a LinkedIn account, because you can pretty much reach out to anybody on LinkedIn. I would look at really cool companies within solar energy, and then I would just reach out to the CEOs and the chemists. And I'd be like, can I have 15 minutes of your time to run an idea that I'm building by you, just to get your feedback? And so week after week, I was going on calls with these people. Not all of them were responding on LinkedIn, but as I put out more content, like more people began to respond as well. And so I started coming up with more and more of a concrete idea for this transparent and flexible solar panel. And then I came up with this concept last year. I know this looks like a sandwich. You may be wondering what this is, but it is a 3D printed model of this idea that I came up with about a year ago. And so now, even looking back on this, my idea has changed a lot because it has been another year has passed. And so now I've been doing more networking and more research. And now I'm trying to actually be able to build this and turn it from an idea into an actual proof of concept. So I'm hopefully going to be working in a lab over the summer to build this out. So I kind of took this framework with solar energy and I applied it to another really big world problem, which is plastic pollution. I think we all know that plastic is a really enormous problem. And last year, I came across this article on LinkedIn. And it was all about plastics. And then towards the end of the article, it started talking about different innovative solutions. And one of those solutions was bioplastics. Bioplastics just blew me away. They interested me so much. They were just so cool to me. And bioplastics are essentially bio-based versions of conventional plastics today. So where our plastics will come from petroleum and coal and oil, which are harmful fossil fuels, bioplastics come from crops like corn and sugarcane and potatoes. And that's really great because it is a lot better than our regular plastics. But when you think of corn and when you look at this photo, you probably don't see a material, you probably see a food. And that's kind of the problem, is that we're using crops that humans need to consume and turning these into bioplastics. And if we wanted to scale bioplastics to the extent that plastics are scaled to, then we're taking out a bunch of food from our food supply, and that's not the most sustainable. It's not even very scalable. And so I started looking into second generation aquatic feedstocks, which are essentially crops that grow in water, so they don't take up land. And they're also crops that humans don't consume. In my research, I came across duckweed. Duckweed, I know it sounds super weird, but it's this aquatic plant, and it can double its biomass in as little as 16 hours, which is really impressive. And it's kind of a crop that everybody hates because it'll grow all over your aquarium and then you have to like get all of it out. But I saw this and I was like, this would be really good for a bioplastic that we wanted to commercialize worldwide. I started researching more and more into this. I started reaching out to people, and one of the people I reached out to was the CEO of Pond Biomaterials, which is a bioplastic startup. And I came across them in my research. They were so interesting. They just won this award. So I reached out and I was like, I'm trying to come up with a new, like a better feedstock for a bioplastic. Would you be available to just go on a call? This was when I was very new into bioplastics. I was just learning. I did not have the idea for duckweed yet. And so I went on the call with the CEO of Pond Biomaterials, again, just by reaching out on LinkedIn. And we started having recurring calls. So as I was growing, I had a lot more questions about bioplastics, like as my research went a lot deeper. And because he had so much experience in this area, he was helping me out with this a lot. Then I came up with this idea for a duckweed bioplastic. I was running it by the CEO of Pond, and he asked me to come and work on this idea at their company. And so that's what I've been doing. And I've also been working in a local university lab because this company is based in Denmark and I am in Canada. So I had to kind of figure out a way to do some lab work, not internationally. But there has been a lot of failure. So these two experiments, which happened literally over the course of like 3 months, they both failed. And so I've been working on getting starch out of my duckweed or degrading the starch in my duckweed. And it has been super, super difficult. I kind of thought that as soon as I got into a lab, it would immediately work and I would have my bioplastic, but there's been so much failure and I've needed to have a lot of resilience. My starch experiment finally worked just a few weeks ago, which was very exciting, but this happened after 3 to 4 months of just straight failure. So it has been a very prominent part of my journey as well, and it's not just immediate success for sure. When I look at my fueling factors, I think the biggest thing is curiosity, which is then fueled by research. So just understanding, just being conscious of different problems in the world and following your curiosity just to see where it takes you. And then from there, when you start going deeper into something, networking with people and utilizing the people around you, I would recommend definitely to everybody just get a LinkedIn account because there's so many opportunities that have come from LinkedIn for me. It's been really amazing just to be able to get feedback from people all over the world. And then the last thing is resilience, because there is going to be a lot of failure involved. Likely there has been for me. And so if you do love what you're doing, then it does make failing a little bit easier, because if you're failing at something you don't really care about, you're not going to have that will to push forward when things do get more difficult. And so that is the third piece of advice that I would give. Thank you so much for your time again. And I think we have a Q&A, so I'm totally happy to answer any questions. And if you want to reach out to me, outside of this, I have a podcast called the Curiosity Podcast, actually. And you can also reach out to me on LinkedIn or on email if you don't have a LinkedIn. So yeah, okay, I will hand it over to Q&A.
Thank you very much, Miss Nyla. So over to the floor. Please ask questions. And like she said, curiosity can take you a long way in the science field. Okay, so whilst we're waiting for the floor to start asking questions, I have a question myself. What is your biggest dream?
I think my biggest dream is actually being able to make an impact within the sustainability sector. Right now, I am more on the idea phase of things and building out proof of concepts of my ideas. But I think my dream would just be to be able to actually impact people with what I create. And so that may come in years, but that's kind of what I'm working towards, because climate change is an enormous problem and it does need solutions very, very quickly. So if I can even play a very small role in helping to end our global consumption of fossil fuels, then that is kind of the dream.
That is beautiful. Oh, there is a question. How do you create a balance between your school life and work in general?
That's a really great question. Thank you. So I think that this definitely is a big thing because I am in grade 10 and I need to balance school as well. And that is kind of my priority because school is super important. So I'm actually joining. I'm joining this from school. I'm going to go to science class right after I get this talk. But I think the biggest thing for me is kind of laying out all of my goals monthly, weekly, and daily. So if I know that I'm going into a very heavy week of school where I have like 3 tests or something, I'm not going to have as much time to work on my bioplastic and do research and code. And I'm going to reflect that in my daily goals. So my daily goals might be like study, like study for this test and like get this assignment done and maybe do a little bit of research. But then if I have a lighter week of school, then it may be like research this, like go on calls with more experts this week and like stack a few calls here, like try to start this coding project or whatever. And so every day before I go to sleep, I'll write down all of my goals. And I think this has come with a bit of trial and error because I've seen now what I can handle and what I can do in a day. And it's not just about doing as much as you possibly can because you want to take care of your health. Number one priority should be health. And so I do like always want to incorporate, being active in my day, walking the dog, and hanging out with friends and stuff like that. And so it's not just like stacking as much as you possibly can to just wear yourself out because it's not scalable. But it's just about knowing what you can take, what you want to get done, and what your priorities are. So if your main priorities are going to be a project you're doing outside of school, and then of course school as well, then you have to figure out how you want to balance that, how much time you want to put forward for both of those, and then also establish goals for both. So if you know that you want a certain output from school, then you have to put in like what you want to get out. And it's the same for projects. If you're not putting in a ton of time, then there may not be very fast results, and that's totally okay if that's like what you're comfortable with, but it's just kind of defining that for yourself.
Okay, thank you. So what I have derived from this is that a scientist is goal-oriented and works hard at achieving those goals, even if they are daily goals. Okay, we have another question. It says, I am also 15 and I tend to get a lot of comments about being too young. Did you ever have to deal with that?
Yeah, no, thank you for the question. I think I definitely do deal with it, like especially when I was just starting out, reaching out to people, and I didn't have any content for what I was doing. I would just reach out to people and they'd be like, why are you reaching out to me? You're literally like, I was 14 when I kind of started reaching out to people. But I feel like you can also use your age to your benefit because a lot of people will be impressed by your age. And a lot of people will be willing to help you if you are young and like working in their field. So if you're working in, I don't know, wind energy and you're trying to build projects here and you reach out to this chemist at a really cool wind company, people are usually very inspired to see youth working in the same fields that they're working in. And they're probably even more likely to respond to you. And so I think that age can definitely sometimes be a barrier in terms of, oh, hey, I really want this internship. And then you check and all the internships, you have to be in university. I've definitely faced that. But I think just trying to get around that, because I think it's just going to be inevitable that some people will think you're too young to do certain things. And in certain things, like you have to get a certain amount of expertise, but by also leveraging it for your benefit and for your advantage, people are usually inspired to see youth working on combating the same problems that they're trying to combat.
Okay, thank you very much. We have another question. It says, where do you see yourself in 5 years?
So in 5 years, probably at university. So I don't know which university. I'm trying to hopefully going to do engineering because I want to go out and build things. So I'll probably be at university doing engineering and then hopefully working on like a side project as well. So I don't know what that'll be. Maybe it'll be like a startup, like working on a company. Maybe it'll be some new project that in a completely different field that I don't know about yet because I know things definitely can change in 5-year periods. So I don't exactly know where I will be, but hopefully still working within climate and trying to build towards making an impact.
That is brilliant. This question says, wow, that is so inspiring. Have you ever encountered a situation where you had to venture into a scientific field that you disliked as part of your research?
I love that question. So yes, definitely. I think for my bioplastic, when I was looking into these different crops to use, looking into second generation aquatic feedstocks, like I mentioned in my talk. And before duckweed, I was actually looking into algae, which is a super fast growing species. I did not know about duckweed at that point, and I was looking at algae because it seemed to be this wonder crop for bioplastics. There are a lot of people looking into it, but the problem with algae is that it's super expensive to harvest. And so I was looking into, instead of how can you turn algae into a bioplastic, because that had already been done, I was looking into how you can lower the cost of algae to produce cheaper bioplastics. And so I was kind of venturing deeper into that field. It wasn't that I didn't like it, it's just that I realized to be able to do this, I would have to kind of work with genetic engineering or like genetic modification and working very deeply in biology and kind of altering this kind of functions of algae itself and like certain kind of contents within algae. And that's not really my favorite thing. Like, I like biology to an extent. I am not like the biggest biology person though. And this was completely biology driven. And so it's something I was not as interested in doing. And I also found myself, like, when I was doing this research, I wasn't as excited to do the research. So I ended up pivoting to looking at a different feedstock. And that's when I found duckweed. And this was like, it's still definitely some biology, but it's more biochemistry. So doing some more chemistry based things. And so I feel like when you get into those situations, it's totally fine. But if it's something you feel like is taking away the fun of it for you, then maybe looking into other things that you can pull as well.
Okay. Next question. How do you navigate being a woman in the very male-dominated field of tech engineering? Thank you so much for your talk. Your work is super inspiring.
Awesome. I love that question as well. You guys have amazing questions. I think it's definitely true that being a woman in STEM can be very difficult at times. I haven't had to face like a massive amount of discrimination just because I haven't really gone to any executive roles or anything like that. I feel like the environment that I've grown up in, I've been super lucky to always have women in STEM like push as a good thing. I actually go to an all-girls school, so I don't really face too much gender inequality at the girls' school that I go to, and it is very like girls can go into whatever they want. Like they can go into STEM, they can go into business, and so this has always been something that was instilled in me from a young age that I'm really grateful and lucky to have had. But there definitely are certain instances where it can feel uncomfortable. I'll give you an example that is a little bit indirect to STEM. It's actually nothing to do with STEM, but I think it's somewhat relevant. So it's actually in sports. So I know your question is about in the field of technology and engineering, but this is kind of just an experience I faced with just being a woman in a male-dominated field. I used to play competitive badminton, so I did that last year. And I was the only girl in my group, actually. They were all boys. And so again, not STEM. Badminton is very different than STEM. But I definitely felt like I was kind of being held at a different standard, even by myself. Like I was holding myself to a different standard because when the boys would mess up, it was like funny. But then when I messed up, I felt like I was like messing up on behalf of like girls because I was literally the only girl and I didn't want to represent badly. And if I was off one day, I would just feel really badly about it. And I feel like there were certain instances when it was very apparent that I was the only girl there. And so it was uncomfortable at times working with a bunch of boys, also my age. So I know boys can sometimes be immature and like teenagers as well. I mean, girls can as well, but there were definitely some uncomfortable instances. And so I feel like in that case, you just have to really understand what you're feeling and understand why you're feeling that. And also know that what you are feeling is valid. But if you are like a girl in a male dominated field, don't step back, like use your voice. It can be really difficult. And sometimes you have a fear of embarrassment, of like being laughed at or not being taken seriously. But just step up and embrace that boss mentality because it's super crucial. Otherwise, you are going to feel like you're not heard. So just make yourself heard. And I know that it's definitely easier said than done.
Thank you very much. This one says, I am writing a novel and also working on science projects just like you. Both require a lot of time and effort and commitment. Do you ever debate on what's more important for you?
Yeah, that's amazing. Congratulations. It's really cool to be working on both of those things. I think for me, I did, especially this year, kind of decide what my priorities were because I had like school and then sports and then STEM and then writing, and it is a lot to balance. And I feel like sometimes when you're working on a bunch of different things, it can be hard to give all of these things your all because you're going to be dividing your attention. And so I think just making sure that if both are something you're really passionate about, keep going with both and just make it work. And just make sure that like what I said before, when you're writing out your goals, like you're incorporating your long-term goals, like your book and your science projects. Maybe you have 1 week where you're focused on your book, another week where you're focused on your science projects. But I think really establishing the goals for both as well is important because I had to make some decisions this year as well. And I'm kind of like pulling a little bit away from writing for this year just to focus more on my STEM projects. I had to drop competitive badminton because I made it to the next level, but it was just a lot of time and it was something that I didn't really want to pursue. I was kind of just doing it for fun. So I still play a lot of sports like in school, just not competitively. And so I think just really knowing what your goals are and understanding the role that these play within your goals, just to make sure that whatever you're doing is things that you do enjoy and that you want to be putting your time towards.
Okay, thank you. This one says, as an innovator and inventor, what is your worldview and perspective on the current world education systems in relation to how they solve real global problems? Are we doing our level best?
That's a really excellent question. I think there's definitely a lot of room for improvement within our education systems. I feel like sometimes they're too, like, I feel like sometimes systems, like when you're taking a science class, for example, it's like memorize a bunch of information and then put it out on a test and then you forget about it 2 weeks later and you're not really retaining that knowledge. I feel like to work on really hard global problems, that's not the skill sets that you need. You need to be able to have something where there's not always a right answer. I feel like sometimes with school, it's a little bit too black and white where there's only one right answer and you have a specific series of steps to get there and then you're right or you're wrong. But that's not really how it is in the real world. And there is a lot of failure in the real world. And I feel like failure is very hated on within school. Like, you don't have someone coming out of a classroom being like, I failed that test, like that was amazing. But in the real world, failure is very, very, I mean, for me, it has been super dominant. Like in the projects that I've been working on, I've had to have a very real mentality shift from this monkey brain where I wanted instant gratification. I wanted it to work immediately. I was really impatient to understanding that these things do take time and there may be failure and there is a value in failure because that means that you tried something, it didn't work, and you're keeping on going. And that in itself, like being able to fail and then persevere, is a skill set that's not really taught in schools. And so, in my opinion, I do think that like school should be less about merit, more about project-based learning, because project-based learning is where you're using that critical thinking and you're really just learning how to learning how to solve real world problems, like learning how to, I don't know, maybe do a root cause analysis on world hunger. That's really cool, right? But that's not something that's done in schools. And so I think it should be less about memorization and actually about retaining that knowledge through building projects and following your curiosity instead of being more confined in a box.
Thank you very much. Indeed, resilience is powerful. Unfortunately, I'll take the last two questions. Does it take a genius to do the works that you are doing?
Absolutely not. I'm not a genius. Like, definitely, I'm not a genius. I think some people think I am. It is not true, guys. I'm sure that a lot of you are much smarter than me. I think what it really takes is just like having the curiosity and the passion for something and then being able to work at it and persevere and have resilience. I really think that's all there is to it. If you have the curiosity about the world to solve big problems and you have that desire, because a desire isn't really something you can force. Like if you have that and you actually want to go and make a real world impact, if you have the curiosity and you have the drive and you have the perseverance and resilience, then you can do it. So definitely does not take a genius, and I'm not a genius either.
Okay, so for the last question. Thank you so much, Nyla, for the inspiration. My question is, what has been your greatest achievement and failure, and how have they both contributed to the present Nyla?
Okay, that's an interesting question. In terms of my greatest achievement, I think maybe it was getting my book published, which is just because it took a lot of resilience and it also came from a lot of failure. So I think I kind of relate the achievement and failure because the achievement would not have happened without failure. So essentially, before the book that I got published was released, I tried to get another book published. And I wrote it, I don't know, maybe when I was like 10 or something, so probably was really bad. But I reached out to a bunch of like agents and publishing houses, and I wrote up a query letter. I even got an editor. And so I kind of thought that this was immediately going to get published. I was not expecting mass rejections in my inbox, but that is what I got. And so the first email that I got was, "This is a subjective business. All you need is one yes." And so I was like, obviously a little bit disappointed, but also like I just reached out to 100 people and she's right. All I need is one yes. So hopefully I get that. And that was not the case. Every day I would wake up to rejections. And this was a book that I had put a lot of time into. I mean, now looking back on it, I read through the book and there definitely were a few gaps. But at the time, like I had put in so much of my time into it and I'd really given it my all. And just the fact that it was getting rejected was a little bit disheartening to me because my dream had been to become a published author. And I did have doubts where I was like, should I keep writing? What if I get rejected again and then I waste my time again? But I did go for it and I knew I wanted to get a book published. And so I wrote another book when I was 12. I got it edited. I sent it out to like publishing houses and agents. And I ended up getting a lot more interest in this, but I didn't know that I was going to get interest in this. There was a part of me that thought this may fail just again. But I feel like if you don't go for it, you're never going to know what the outcome is. So even if you're afraid that there may be failure, don't let that stop you. Don't let you be your biggest barrier. Just go for it. So I think that was kind of biggest achievement and failure all in one.
Thank you very much, Ms. Nyla, and thank you all for participating and coming through with your question and answer. And thank you, Ms. Nyla, for answering. Unfortunately, we have come to the end of our live. So feel free to join the same time again tomorrow, and all the best to our finalists.
Awesome. Thank you, and good luck to all of the finalists. Bye.